So earlier this week, I built a robot that is controlled via Bluetooth. Um, it is built using a Pic32. The Pic32 is inside of this mini development board called the Micro Stick. I hope you can see that here. It makes programming the PIC very easy because it can be powered and programmed via a USB port, USB cable, excuse me. Um, Yes, and I have a USB power bank under this breadboard. I don't know if you can see it. That's what I'm using to power the pick when the robot is running. I'm trying to get an angle of it. Yeah, I mean, it's pretty easy to see. That's powering the pick, and I have a 6 volt, well, 4 AA battery pack. You might not be able to see it from here, but it's right here where my finger is touching. Um, 4 AA battery, so 6 volts, and that is powering the two DC motors. I'm sending the that voltage into this motor driver right here. This is the TB6612 from Adafruit breakout board. Um, it's powered. It can be powered from anywhere between 5 to 13 volts. So the 6 volts from the battery pack works perfectly fine. It also controls the PWM for the motors to be able to change the speed that the motors run at. Um, so the way the robot works is I pull up a Bluetooth terminal app. Since I'm using an iPhone, it's a Bluetooth low energy app. That's what iPhones use. I think with iOS 10 is what they started. It could be earlier than that. I'm not too sure. Don't quote me on that. But I do know that um, it has to be Bluetooth low energy. And this right here is the actual Bluetooth module. I don't know if you can see it right here. It's not on. The pick isn't on, so it's not being blinking or anything like that right now. This is the Adafruit Blue Fruit Low Energy, the UART version. So that's what so the whatever Bluetooth terminal app, low energy app you use connects to that, and you send commands. The commands are in the form of a single character, either U for up or forward, D for down or backward, L for left, R for right, S for stop, and a number. So it's a character and a number. The number it ranges between 1 to 4 for the 4 different speeds, or four different speeds, but 4 base speeds that you can choose for the robot. I did that because that's how I'm using those numbers to later calculate the duty cycle, and just a way to bed. I make sure I cap the duty cycle so it goes no lower than 20%, which is probably the slowest that the motors actually move, and the highest is 80%. Because that's about it, the way it can move fast, but not ridiculously fast, like when it's at 100%. Running at a frequency of 250 hertz for the motors. Like I said earlier, the duty cycle is capped between 20 and 80%. Um, I do have input validation. So if you enter a number less than one for while changing or while you're changing direction, it automatically reassigns that value to one. And if you put a number higher than 4, then that number gets reassigned to 4. And when you're sending the stop command, you can only use the number 0 to make sure that that kills the duty cycle. Just, I mean, the function of itself stops the motors, but that's just making sure that the duty cycle itself stops. So that way there's no funky behavior later on when you restart the motors. And even if you enter another number other than 0, while you enter the command S, it's always going to go back to 0. Onto the code. So on the PIC, I'm running a threading library known as Proto Threads. It's a very lightweight, stackless library, pretty much in like all macros. And that's what I'm running. I have 3 threads running on this robot. I have a motor thread, a Bluetooth thread, and an LED thread. The LED thread, I'm sorry, the Bluetooth thread is the thread that handles the communication between whatever Bluetooth low energy terminal app and the Bluefruit right here. And it's what sends strings to the Bluetooth terminal app and receives input from the terminal and parses those commands into the appropriate parses them appropriately. Excuse me. And now the motor thread is what it does just what it sounds like. It moves the motors. In the motor thread, I take the whatever character that was sent. It assigns a value to a flag called robot movement, motor movement. Excuse me, or it could be robot movement. I don't remember the name of it. And based on the value of that, it passes that through a switch statement, and then based on whatever case executes, it'll implement the forward moving function, backward moving function, left, right, or stop moving function. Also in the motor thread, the duty cycle is calculated, which is information that was once again gotten from the motor, not the Bluetooth thread when it was parsing the command that was sent. I said there's four base speeds. The number doesn't have to be an integer. You can enter in floating point, but it's going to be no greater than 4 and no less than 1. So if you enter in a 1, the duty cycle is 20%, 2 40%, 3 60%, 4 80%. And then any numbers in between that you decide to use. And the LED thread just blinks an LED every. I have to go back and look at the code on. I really don't remember if it's every second or every half second. I believe it's every second. If you want to look at the code, it is going to be in my GitHub. I'm going to leave a link to the description, a link in the description to my GitHub, so you can look at the code for this particular robot, so you can look at the thread yourself. But that thread was pretty much just for debugging, just to make sure that because all the threads are non-blocking, so I used that thread. Like if the LED wasn't blinking, then I knew I had something in another thread that was blocking and needed to be fixed. So that was pretty much the debugging thread. There's no real need for me to blink an LED. The PWM in the motor thread is implemented using 2 of the output compare units on the PIC, and they're run off timer 3. The system clock that I'm running at is 40 megahertz, and that's set in my config.h. Not config.h. Yeah. But that is it for the technical overview. Now on to the demo. As you see, I'm now recording my screen, but I'm also showing some other angles of the robot. As you can see, I have an LED that is blinking every second. Now, I don't know if you can also see, but the Bluefruit, the LED on the Bluefruit is blinking red twice, so nothing is connected to it. I'm going to go ahead and connect to the Bluefruit now. And it was successful and open the UART terminal. I actually made a mistake. I don't know why I said that. I think I'm running at 250 hertz. I'm actually running at 1 kilohertz. I was testing out at 250 at one point, and it was like 3 in the morning, and I completely forgot that I ended up changing to 1 kilohertz. I'm going to go ahead and start off with moving forward. Let's do 1. As you can see, it moves extremely slow. For the sake of this, I'm going to let it move a little bit more. Now I'm going to stop it. Okay. Now I'm going to move it backwards a little bit faster. Let's do B2. Wow. Not B2, D2. That's embarrassing. And then we're going to stop it. Okay, so that's the second speed. Now for the third speed, because it's going to start moving a lot quicker, I'm going to show these speeds with the turning left and turning right, because I don't want it to just crash into something. So let's start off with turning left at 3. And then let's just go ahead and jump to the right. And that's the fastest speed. This is the duty cycle at 80%. Now, as you can see, if I change it to, let's do this, let's do negative, let's do 0 actually. And time it so that it's running everything. It moves very slow. And if I change it back and I enter in 8, it says change into 4. So it still maxes out at maxes out at 80%, or goes as low as 20%. It doesn't do anything else. So let's go ahead and stop the robot. I can also enter any number. It's just going to default to 0. And that is it. The robot spins. I've got a weird angle set up for this video. I do apologize if it's hard to see, but yeah, I'm trying to center the robot now a little bit. Let's go ahead. And that is the end of the demo. I'm going to leave a link to my GitHub where I have the files needed to run the robot. I'll leave a link to that particular folder, which you can just navigate through the repository or other repositories if you would like. I'm going to leave a link to my blog, where I pretty much blog about the updates that I'm making on different projects that I'm working on. Please like, comment, and subscribe. I'm going to be making more videos like this. And yeah, that's pretty much. Oh, and turn on the post notifications too, so you will know when I post another video doing another project or some kind of breakthrough. But thank you so much for your time, and I hope that you visit my channel again.